Yes, today we are back with a challenging problem and a hard problem. Today's problem is very challenging problem because this problem deals with the arrays. So if your concept of arrays is not very clear, then you won't be able to understand this particular problem. So in order to understand this particular problem, what we're going to do is we're going to find out the differences which becomes maximum. So it's basically that we have to find, the question is minimize maximum distance to gas station. So it's like we will be given a horizontal line. On the number line, we have gas stations at position 0 to n-1, where n is the size of the station's area. Now we add k more gas stations so that the distance between the gas stations is minimized. We have to find the smallest possible value of the d and find the answer exactly. So it's a big question. I will explain it in a very simple manner. So first, let's start with the problem. Okay, and now I'm going to explore this particular problem. So first, before exploring this problem, what we have to be very clear about it is we have to suppose take an array. Okay, so without taking an array, you won't be able to particularly understand whatever it is going on over here. So first, initially, I'm going to take an array, say arr equals to, I'm going to place the elements 1 to 4. So 1, 2, 3, 4. These are the elements I have placed. Okay, now I'm going to take a k equals to 4. So k equals to 4. That means 4 elements I can insert either between or in the end. Okay, so let me just check the difference. Let me just check the difference if I put it at the end. So if I put it at the end, so I will, case 1 is, if I put it at the end, so the array will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if I see, if I have put 9, so there are 4 elements which I have inserted just after this. Okay, just after this was my initial array, and I have to add 4 elements. Then the total array length is still 9. Okay, now I have to check the differences between the individual gas stations. So the difference is 1, over here it is 1, over here it is 1, and again over here 1, 1, 1, 1, 1. But my condition is this really a good way to define a gas station? Because why we are going to go to the end and then add all the gas stations? Then what is the point of minimizing the cost? What is the point of maximizing the distance? So all these things, this is okay, it has the maximum distance of 1, okay, but we have to try something more innovative, something more easier, okay, and more valid to the problem statement. So this is ruled out. Okay, so now what we can try and explore is a second case. So in the second case, I will take between 1 and 4, 1 and 2, 4 values. Okay, so I will just put it like this, 1, and over here I am going to put 2, and over here I'm going to put 3, 4, and 5. Now what are the values I'm going to put? So this becomes interesting now. Okay, so I'm just going to quickly change the color. Yeah, so over here I can write it as 1.25, and I can take the next value as 1.5, next value as 1.75. okay, similarly between 4 and 5, what I'm going to take is a 4.5. okay, now let us check the difference. Okay, so in each case, whenever we are doing this problem, we have to check the difference. So while checking the difference, you have to be very careful. See, between 1 and 1.25, what is the difference? It's a 0.25. This is the difference, 0.25. Again the difference is 0.25. Again the difference is 0.25. Now between 2 and 3, the difference is 1. Between 3 and 4, the difference is 1. This is 0.5. This is 0.5. So you can see how many values I have inserted between. So 3 values I have inserted over here, and 1 value I have inserted. So total, if I am fulfilling the criteria, I have inserted 4 values. Okay, but over here what you can see, the maximum is 1. Why? Because 1 is the maximum gap which is occurring most number of times, and the highest value is max 1. Okay, so this is one example. But if I want to further classify it and check the another value, okay, so check the another value. So if I'm going to take another blackboard, okay, I'm going to put it as black. Okay, over here what I'm going to explore is just give me a second. Yeah, so over here what I'm going to explore is, I can take the difference in such a manner. So I will change the difference like this as 1, 1.5. okay, and I can check the difference as 2, 2.5. okay, and I can take the difference as 3, 3.5, 4, 4.5, and 5. So how many values I am inserting? So these are my original elements. Okay, so be very careful. What are your original elements? So these are my original elements. 1 to 5. I'm inserting how many values? I can insert 4 values. So one value inserted over here, second value, third value, and fourth value. Now if you see in all the conditions, what is the difference in each of the cases? The difference is 0.5, because over here 0.5, 0.5, 0.5, 0.5, and the list goes up. Okay, so difference equals to 0.5. So if you see in a case like this, 0.5, and if you see in the previous frame, what are the differences we have obtained? We have obtained difference of 1, which is ruled out. Second one is also 1, and 0.5. So according to our question, we have to minimize. So out of all the 3 previous possibilities, 0.5 is the minimum value. So this is the question. So in what possibilities and what combinations you can do it such that you find this minimum difference? Okay, this was one question. So we can solve it using brute force. We can solve it using brute force. Very simple logic. Brute force algo we can use, and we can solve this. Okay. And if you want to analyze the given example of given example 1, 2, 3, 4, 5, I have already explained. Okay, so in the given gas stations, in the second example is also there. There can be a number of examples. Okay, but we will discuss about these examples with the code. First, we will write one code, and then we are going to discuss about this example. Okay, so yeah. So over here, first we can see that we have to find small maximum. Find the smallest maximum distance. Okay, so finding the smallest maximum distance, we have to find the number of gas stations as well. So first, before going into this function, I'm going to write a function which is public static int number of, say, number of gas station. Okay, so in gas station, what I'm going to take? I'm going to take an integer array, a double value, double distance. Okay, we have to take double values because the list can be really long. So int, or if you check the driver codes, it is double. So in count equals to 0, if I do, there's a counter, and int n equals to arr dot length. Okay, now we are going to simply run a loop for int I equals 0 less than n minus 1 I plus plus. Now what I'm going to do is double. I'm going to take a variable, so stations in between. Okay, this is the double in between stations. So what I will do is I will check the adjacent elements difference. I plus 1 is the adjacent element minus the current element. Okay, divided by distance. So where I'm getting this distance will be given. It is basically nothing but k. Okay, so count plus equals to stations in between. Okay, semicolon. I've done this. I'm going to return counter. Okay, now in my max double function, what I'm going to do is, in my max double function, I'm going to take int n equals to arr dot length for the length, double maxi equals to integer dot min underscore value. Whenever we are working with variables which can become really long, then you have to take this minimum value for maximum. I've already told you in my previous videos. So for I can take a loop over here. In this loop, what I can do is I can traverse the loop from int I equals to int I equals to 0 till I less than n minus 1 and I plus plus. Over here I can write maxi is equals to math.max of maxi, which is I'm getting as a minimum value, comma double of, I'm going to typecast this because the next array is going to be an integer array. So arr of I plus 1 minus arr of I. Okay, then I can just close this function. I'm going to do binary search again. So this is done using binary search. So double low equals to 0, double I equals to maxi, double mid, or you can say difference. In this case we will take difference equals to 1 e minus 6. So what is this? 10 to the power minus 6. This is a taking. These are the constants we are taking. So because if this crosses our floating point boundaries, then we have to take all these constants. Then we have to do the binary search. We are doing this every day. low less than equals to high. So in this case, since we can't just do low less than equals to high, we are going to take a difference, right? So high minus low greater than difference in this case. So in this binary case, what we are doing, while loop we are going to run, we are going to, as usual, take the middle value. Mid equals to low plus high minus low by 2. Okay. Now I am going to call this function if number of gas stations. So I'm going to call this function if number of gas stations in between, and I'm going to pass the values ARR. I'm going to pass the values ARR, mid, 2 values. Okay. So is less than equals to, total number of gas station has to be less than equals to k, because k is given by user as the intervals. Okay, so what you can write in the intervals, high equals to mid, else low equals to mid. Okay, once the while loop is done, you can return high, close of the function. Wait a second. So we have to close the for loop as well somewhere, which we started. So okay, so this for loop ends over here. So what we have done is I can see my code is perfect. Error of I minus 1. Okay, so now I'm going to compile and submit. So you can see there are 11,000 test cases. Not 1, not 1,000, but 11,000 test cases. So how it works? So we have successfully completed our today's problem, and we are looking forward to see you in the next video.